Swayam Prabha. Digital India. Educated India.
Let's go ahead with the next important aspect of this coordinates, that is which involves the angles. So we have seen the Cartesian coordinates, we have seen the polar coordinates, we have seen path dependent coordinates, and also we have seen how to represent spherical coordinates. So when you go into this kind of generalized coordinates, spherical coordinates, so there we also take angle into consideration. So whenever the angle changes, obviously it will be construed as rotation. And so we have to establish one fact here. So one fact is that since we are dealing with vectorial mechanics, so we should be sure that what can be added and what cannot be added. So if, for example, one of the fundamental properties of any vectorial algebra is that if you have, there's so many properties. One of the thing is that if you have a vector A and if you have B, and if you add A plus B, okay, should also be equal to B plus A. There's so many linear things, okay. So that kind of ordering should be immaterial as far as these vectorial spaces are concerned. So whether you do the second operation followed by the first operation or first operation followed by second operation, everything is an operation. Should be same. So this is something which we have to establish, so which we have to understand rotations. So there are rotations which are finite, so that means that significant, and there are rotations which are small, very, very small. So like theta is a finite rotation if you take it, then we say delta theta is a very small infinitesimal rotation. So we have to understand those things. So one of the things that we come across is the rotation, is that finite rotations. So for example, if you take this one and if you rotate it by this, and then if you rotate it like this is what you get, right? So the same thing. So if you rotate it like this first and then followed by this one, so obviously you can see that the end result is not the same. So it looks like the rotations cannot be added commutatively. So it cannot be just added A plus B to be equal to B plus A. So these small things which will tell you, right? So in fact, maybe I have a couple of slides in which I tell those things. So, but however, rotations, we say in small measure can be added. So let's have a small slide which I show you here. Yeah, this is what I was telling. So if you hold this fast and then if you rotate it like this, okay, and then rotate it like this, so you will end up like this. So similarly, if you hold like this and if you rotate it like this and rotate it like this 90 degrees, so this is what I was telling. So the end result is not the same, right? So what we do here is that I have another thing which shows that if you have these things in a very small measure like delta theta, instead of 90 degrees, if you take it to be a very, very small quantity, so you will see it. So the next slide here is about, let us say, the vertical axis is z axis, and the one going to the left is x axis, one going to the right is y axis. So x, y in the ground, and z is up here. So here what we have is that, maybe I'll just, I'm not sure if you can see this. Can you see it? So okay, so you can see the, so what we would like to do is that we are doing two operations. So theta 1 and, or maybe theta z and theta y. So when you have this, so the one, if you do the first operation, so the point P here, for example, if you rotate it about z axis, so then it will go like this, right? So you can see it there and point. And then after that, if you rotate it through z, then this point will go on a circle like this, and by a small amount. So P goes to P prime here, and then, so this is theta z, and this is theta y, and you will end up with a q prime here, right? So here first we did theta z followed by theta y, and then p to p prime to q prime. So that's how, so this is first is theta z and then theta y. So on the other hand, it's also possible that we can go first about theta y, so like this, so p to p double prime, so this is with operation theta y, and then p double prime to q double prime using theta z. So that means that it goes like this. So this is q double prime, right? Q double prime. And so you can see that this sequencing of operations is very crucial here. So in fact, that means that the end point here, q prime, where you went like this, or the end point q double prime, you went like this, by the same angles. So that means that this q double prime and q prime does not match. So this is as far as these rotations or finite rotations are concerned. So when you make this rotation smaller and smaller, what will happen to this one? So let me just show you the next slide. Yeah, this is the exactly the same thing, except that the angles are much smaller, and so the two operations like this and coming here, and like this coming here. So this you can very clearly see from this figure that these two distances are going to be smaller and smaller when the angle theta z and theta y are becoming smaller, and actually they coincide when this rotation angles are tend to 0 or infinitesimally small. Okay, so this picture will give you exactly what happens when finite rotations do take place and whether there are infinitesimal rotations do take place. I hope you are convinced that at least by this demonstration, you can actually see that the infinitesimal rotations are going to be same. So now what we would like to do is that we would like to prove this in a rigorous mathematical sense. It is indeed so that the rotations, when they are finite, they will not be, cannot be considered as vectors, but they are very small, they can be considered. So how is that going to be thing? Okay, so this is what I'm going to spend some time. So here what we have is that the XYZ axis, exactly similar thing is there. So then there is a arrow here. Maybe I'll just show it with my, so this line is say vector, small vector n, unit vector along this one. The point P here, this is the point P. So OP is the original vector, and this axis is a rotational axis. So the vector here is going to be rotated through an angle theta. So when it rotates angle theta like this one along the arc here, so it's going to occupy this position. Okay. So we would like to see how this P to this OP, which is originally here, when it takes a position P prime, so there is a vector we call as delta R. So how can we exactly get a relation for that in terms of these things? Okay, so some of these things so what we are saying here is a rotation about that axis by a small angle. P goes to P prime by a small angle, say let us theta. I mean, it's a finite rotation. It's a theta. So when it takes that, we call that Q1 maybe. So what is that? So P to P prime going to be? Okay. So how can we get a measure of this? So a little bit of so if you are convinced about the orientation of this one, there's a little bit of 3D imagination. So you should get into this 3D imagination. And so we'll be a little exercise. I'm sure you can do that. You have gone through AutoCAD. I'm sure you have gone through a lot of physics and so on. So we will do a little bit. Okay, I'll try to explain it as slowly as possible. So let me stop this one. So I hope you had that picture in mind, and so I'm going slowly. First, I demonstrated by a simple thing that using 90-degree rotation about Z and Y axis is not exactly, not at all, very clearly. And also here, with these two slides, I have explained that finite rotations are not commutative, but when it is small, so the discrepancy there comes down to tends to 0. So let's try to do it with I hope you're getting the picture here. So this is what we are trying to do here. So what we have here is that we have OP here. So OP, we call it as OP is a vector. OP is or not, and if you need, so OP is a vector here or not, and this vector OP or the point P is being rotated about the rotational axis N here. N is the rotational axis. So, and then rotate by theta. Okay, so it's being rotated in some usual sense. And so that means that this P, so P here goes through an angle of theta along the arc. So then it comes to the point P prime here. So that means that this is OP prime is R naught plus delta R. Let me call it as delta R. And so PP prime is delta R. So that is the change in the vector PP prime, right? So now we have a little bit of algebra here. And so let's also see here, if you see it from top, so if you see from the top, the N is coming out, and this is P, and this is P prime. So let's draw it a little bit bigger. I'll draw it. Okay, so this is P and P prime, and this is angle theta. So I'll ask you a few questions. So that means that what do you think of this N cross R naught? So N cross R naught, if you take a cross product of N with R naught, so it is nothing but, so this is some angle phi between these two. So it is nothing but N R naught, and so this is equal to the magnitude of this one is N, so R naught sine phi, R naught sine phi. So if it is R naught sine phi, can you find out what it is? So if you imagine that this circular disk is perpendicular to the line, this plane is perpendicular to this plane of the circle is perpendicular, so that means that this angle is 90 degrees. So that means that, so if I see here, so O, C, and P here, and this is phi, and this is R naught, and this is the vector N. So if you take a cross product of these two, so then this being 90 degrees, So this cross, this one is nothing but this radius. So if you call this as some radius R, A or maybe this is, so this is CP. So that means this n cross P is nothing but CP, and the magnitude of this one is nothing but CP itself. Okay. And what is the direction? So you have this and you have this. So n cross or not then will be perpendicular to this plane. And what it will be? So if you look at that one, then what is that it's going to be? So n is coming. So P is coming like this one. So that means that if you look cross product of these two, so then it is nothing but it's perpendicular to this plane. And let us say, so this is a vector, let us say M. So M is nothing but, so M is, what is the direction of M then? So M is in the plane of the circle here, right? And it is 90 degrees to this one as well as this one. So that means that it is 90 degrees to so the unit vector M here, the direction of this one, so it is CP, the direction of M. Okay, I hope you can imagine that, right? So it is perpendicular to this plane, it's perpendicular to this plane, so obviously it has to be in the plane of the circle here, and it is also perpendicular to this plane. So that means that it is perpendicular to this one. So it is something like here and it's here. So it should be perpendicular to that. So this is in this direction. So and then its magnitude is CP. So if that is case, then what will be that? So that will be that if you take it to be parallel. So let us say this is Q. So it is parallel to QP prime. Okay. So this is parallel to, and its magnitude is CP. And if this is theta here, so let us say if I multiply it with what is that? So it is, this is CP and CP sine theta. So if you look at this one, CP sine theta M, okay, so that CP and CP prime are same, and sine theta, so it is nothing but QP prime. So this is nothing but the vector QP. So you can see QP prime in the direction of M, and CP prime sine theta is nothing but QP prime, and QP prime in the direction of M, so it is nothing but QP prime itself. Okay, so this is the interesting part here, and because ultimately we want to get PP prime. So one, the component QP prime, we got it. Okay, so and then I would like to do another. This is one. Consider, so I'll take another cross product with N. So I will take another cross product with N before. So that means that there's an N here, and then I have here, I have N cross or not here. So that is this vector. Okay. So if I take this cross product of this one with this one, so that means that, so if I take a cross product from this to this, so it will be a vector going in this direction, in the direction of, so this is in the direction of P to C. Okay, so that's in the direction of P to C as well as, and its magnitude, you can see that its magnitude there is Cp itself, and magnitude is as we have done here. So if I want PQ, so if I just want this magnitude PQ, so it is, if I want the PQ, okay, the direction is anyway in this, its magnitude is PC. So what if I do as 1 minus cos theta, so that will become so you can very well see that its magnitude is PC, but multiplying with this one, multiplying with 1 minus cos theta, so then that's nothing but PQ itself. So this is all what we have. Very interestingly is that finally what we have here, is that PP prime is nothing but P cube plus QP prime, which we have done just now, is that 1 minus cos theta n cross r naught plus sin theta n cross. Hope you got the picture. So this is the final result. So we have did a lot of algebra here, manipulation, and finally, so PP prime is nothing but delta R. So this is the, so that means that when R naught is rotated by an angle of theta here, so this is what's going to, this is what we are going to find a change delta R. Okay, so delta R is given by 1 minus cos theta, n is the rotational axis, and then it is rotated by an angle of theta, and the total delta R is like this one. So this is completely an exact result, whether it is theta is small or theta is finite, right? So this is delta R. So what we would like to do here, interestingly, so obviously it is also equal to, if you have say OP prime, which is the new R prime, is nothing but R naught plus delta R. So this is the end result of it. So the new vector is nothing but R naught plus delta R. Okay, so let us do, we are interested in finding out what is the sequence of operation going to affect. So let us do one thing, in the sense that two rotations. So theta 1 about n1 axis and theta 2 about n2 axis. Okay, so what we have here is that, yeah, what we are trying to do here is that same as earlier. So there is a theta 1 operation here. So this P R naught becomes R naught plus delta R. So P to P prime, and then P prime to P double prime. I hope you have understood here. So just like we did, P to P prime by a rotation of theta 1, and P prime to P double prime by a rotation of theta 2 about N2 axis. So that's what I've written here. So that means that POP is originally R0 and P prime is delta R1 due to rotation, theta 1 about, I'm just writing it again, and P prime to P double prime is, I can say, rotation of R0. Okay, here P prime to P double prime is, let us say, delta R2. So this is due to rotation of R1 by theta 1 about, I hope you have understood. One rotation POP has become OP prime by a rotation of theta 1, and after that the same point P prime now has moved through P double prime, okay, by a rotation of theta 2 in the about N2. So the equations are a little longish, but I'll just write it because these are very important. See, the mechanics is very, very rigorous. It's not something people just do it by hearsay or something like that. Okay. So now let's put this in the form of equations. So this P to P prime, which is delta, let's call it as delta R1, is nothing but whatever we have done there, but I'll put it as 1 minus cos theta 1 and 1 cross N1 cross R0 plus sin theta 1 N1 cross R. Okay, so whatever we have done. So now, so here obviously OP is R0. So in the next stage, our vector will be OP prime. So OP prime will be R0 plus delta R1, right? So this is all in sequence. Now P prime to P double prime is the same thing as here. We call it as delta R2 is 1 minus cos theta 2 N2 here I'll put R1. Okay, be careful. Earlier it was R0, now it is R1, updated vector here. Plus sin theta 2 N2 cross R1. Okay, so then, well, the R2 will be the updated one, is nothing but R1 plus. Okay, so this is the sequence in which we put down two rotations, one after the other. First is a rotation about axis N1 of angle theta 1. The next is theta 2 about N2. Okay, so you can see that this involves a lot of trigonometric terms, and so this final delta R2, yeah, final delta R, which was delta R1. So clearly this is not same as in the sense that you put theta 2 about n2 first, and theta 1 about n1 in the next step. So obviously the sequence, there's so much involved and it's not very clear. I mean, the expressions are very long and obviously the terms are not same. Okay. So what we do here is that if that is the case, so I was all the way hinting that we have. So however, what we do, however, if thetas are small, let us say theta 1 is say delta theta 1, then what happens here is that this 1 minus cosine theta 1 will become 1 minus delta theta 1, and this we know that it's 1 minus delta theta 1 square by 2. You know that this is the expansion, and this is approximately for the first term, this is delta theta 1 by 2, right, when theta 1 is small. So similarly, the other one, of course, you know very well. So this sine delta theta 1 is going to be delta theta 1 minus okay. So this is, you know very well that sine delta theta 1 can be approximated by the angle delta theta 1 itself. So these are two expressions. So if that simplification is made here, for example, this pp prime will become, this becomes delta theta 1 square by 2 and 1 . Okay, so this is how it looks like for the first approximation, right? And so if you consider these two, there is a delta theta 1 term here and delta theta 1 squared term here. So the first term can be neglected because it is, so first term can be neglected. Okay, so then what happens is that pp prime will become, so this whole thing, this is a higher order when delta theta is really say 0 0 1, so then delta theta square will become 4 zeros 1, so which is extremely small and further becomes small. So that means that this delta theta 1, okay, so this is the interesting part here. So it is very nicely approximated to be. If that is the case, so then can we go back here and simplify the whole thing? Okay, so if you go back here and simplify, so pp prime will become, maybe I'll just write it here. So pp prime will become delta theta 1 and n1 or not, right? And then op prime will become or not plus this one, and right. So then p prime, p double prime, this is the next one, will become what? So the same thing here. So this will be now delta theta 2 and 2 into, this is R1 So this will become delta theta 2, and 2 times R1 is okay. So you can see quite clearly here that this is delta theta 2 N2 R0 and delta theta 2 delta theta 1 N2 1. Okay, so like this. So what we have here again, so this is very, very small. So this becomes only this much. So the total delta R will simply this one Pp prime will simply become delta theta 1 and 1 or not, and delta theta 2 and 2 or. This is the interesting part here. Yeah, maybe probably making that assumption. So Pp prime is delta theta 1 and 1 or not, and the new vector OP prime will be R0 plus this one, which becomes R1. Then the next increment P prime P double prime will become delta theta 2 N2, and here we have R1, in which place we have substituted this. And again here, so there are two terms. The second term is higher order delta theta 2 delta theta 1 multiplication. So it is approximately 0. So finally this is the 1. Okay, for this one. So the total delta R is delta theta 1 and 1 R0 plus delta theta 2 R2 N2 R0. So this is very clearly, so this is also it will become, so if you change sequence also it will become, if you change the order, so it will become N2 R0. So obviously you can see that this is same as this one. Even if you change the order, so the delta R is same, right? So this is what I was trying to tell you, that when the rotation angle are small, so then the sequence of rotations do not matter, and then it will be completely, it can be then. So finally we conclude so we can see rotation delta theta 1 and delta theta 2 order does not affect delta R. Okay, so this is a very important conclusion. So what we have here is that whether you do delta theta 1 delta theta 2 or reverse, so the final result is the same, either this or this. You can see they are identically same. Okay, so therefore we can finally we can say, so this is also important for us. So it is delta R is delta theta. I'll remove that. So this one is finally what we use. So why we use it? What is the implication of this one? The implication of this one, if this is infinite small changes delta theta and delta R, so then dividing by delta t, so then we have delta R by delta t is nothing but delta theta by delta t and n cross R. So this is nothing but, so the velocity here is if this is theta dot n, So what is this theta dot n? So n is the velocity, angular velocity, the axis about which it is rotating, and theta dot is the angular velocity. So combinedly, you can put it as omega also. So this is a very important result. So the velocity here, the linear velocity is nothing but omega cross r naught. So if you have angular velocity taking place about any axis, so then take cross product with r naught vector, then that will give you the velocity. Okay, so this you remember, and we'll continue this one to really explore, further understand the spherical coordinates. So spherical coordinates, if you recall, there is a change in the vector length, which we call as delta r. Apart from that, we have delta theta and delta phi, which are going to give you the change in the angular orientation. Okay, so together they form the total coordinate system. So how do we take care? So if there is a change of r, if there is a change in theta, if there is a change in phi, so how do we calculate the velocities? How do we calculate the acceleration? Okay, so I think I'll stop here.